Dear students, welcome to the next part in the coordination chemistry. So in this session I am going to take some points on geometrical isomerism exhibited by coordination compounds with coordination number 4.
So, compounds having same molecular formula but different structures are called isomers, and the phenomenon is called isomerism. Due to different structure, the physical and chemical properties also differ. And in isomerism, we will come across structural isomerism and stereoisomerism. In structural isomerism, the isomers they will have same molecular formula but have different structures. In stereoisomerism, compounds will have same molecular formula, same structural formula, but different spatial arrangement of atoms. They are called stereoisomers and the phenomenon is called stereoisomerism. Stereoisomerism is further classified as geometrical isomerism and optical isomerism. Now, let us take first geometrical isomerism. So, in complexes of coordination number 4, isomers in which ligands occupy different position around the central metal ion are called geometrical isomers. The phenomenon is called geometrical isomerism. So, in this structure, if similar ligands occupy adjacent positions to one another is called cis form. If the similar ligands occupy position opposite to one another, the isomer is called trans form. So this is cis trans isomerism. So the complexes with coordination number 4 can adopt two geometrical shapes or structure. One is tetrahedral and another is square planar. In tetrahedral complexes, cis-trans isomerism is not observed or not possible since all the four ligands around the central metal ion are adjacent to each other. Now, let us see geometrical isomerism in square planar complexes. So, in square planar complexes, complexes of type MA4. M stands for central metal atomer ion, A for ligand. A is one kind of ligand, B is another kind of ligand. So complexes of type MA4, MA3B or MAB3 does not show geometrical isomerism since all the possible arrangements of the ligands for these complexes are exactly equivalent. Complexes of type MA2B2, MA2BC, MABCD, that is with different kinds of ligands, show geometrical isomerism. So let us consider the complexes of type MA2B2. So is the square planar structure. The ligands are adjacent to each other. This is a trans form. In this, the ligands are at the position opposite to one another. So, it is a trans form. So, cis-trans isomerism can be observed in the complexes of type MA2B2. So, in this type, for example, we can take diamine dichloroplatinum complex. So, here the same kind of ligands are adjacent to each other. This is form. Here they are in opposite position. This is transform. So in complexes of type M, A, 2, B, C, that is three kinds of ligands are there. Here, if we consider ligand A, it is in the adjacent position. This is cis form. Here, it is in the position opposite to one another. This is transform. If we see an example for Ma2Bc type, so A stands for pyridine ligand, one ammonia, one chlorine. So amino chloro dipyridine platinum complex. So ligand pyridine is adjacent to one another. So this is cis form and they are opposite to one another. Then it will be transform. In the complexes of type M, A, B, C, D, where all the four ligands are of different kind, three isomeric structure are there. So in the first structure, for the ligand A, B is in the trans position. In the second structure, C is in the trans position. So one structure, another structure. In the third structure and the fourth structure, A is trans to D. Here also A is trans to D. So both the structure are identical. So overall three isomeric structure is formed. So for example, for MABCD type, we can see all the four ligands are different. So here in these three structure, we can, if we fix the position of NH2OH hydroxyl amine in one position, and we can see for this ammonia is at trans position in the first structure. In the second structure, for this pyridine is in the trans position, and in the third structure, NO2 group is in the trans position. So, three isomeric structures are obtained by fixing NH2OH at one position. Now let us see square planar complexes with bidentate ligands. Till now we have seen square planar complexes with different monodentate ligands. So in square planar complexes with symmetrical bidentate ligand of type MAA twice MAAB2 or MAABC do not show geometrical isomerism. AA stands for bidentate ligand. Square planar complexes with unsymmetrical bidentate ligands such as MAB twice shows geometrical isomerism. AB is a bidentate ligand in which it has two different donor atoms, like glycinate in which it has got two donor atoms, one is nitrogen and another one is oxygen. So the example for this type of complex is diglycinato-platinum 2 complex. If we see the structure, it exists in cis form and in trans form. So in cis form, the ligand is attached in this way: nitrogen donor atom, oxygen, nitrogen in this ligand and oxygen. So here the donor atoms attached is exactly reversed. So nitrogen donor atom in this ligand is exactly opposite to that of another ligand. So this structure is transform and this one is oxygen. We have come across stereoisomerism in coordination compounds with coordination number 4. And stereoisomers are classified into geometrical isomerism and optical isomerism. So in geometrical isomerism, if you consider tetrahedral complexes, in this cis-trans isomerism is not observed. In square planar complexes, only complexes of type Ma2B2, Ma2BC, MABCD show geometrical isomerism. Thank you.